We talked about some of the surface features of Mercury, and I had told you to remember in this picture right here that there's this sort of ripple or crack across the surface. So if you look carefully, you can sort of see that right between those two lines, there's a discontinuity right there, that cuts right across a crater and right across the surface of Mercury. Well, we see these in several places on Mercury here. And these are what we call lobate scarps. The lobate scarps are actually these regions here on Mercury in which the ground has shifted. These are like thrust faults. So what happens is that if you compress the ground, then it'll crack and one side will slide up over the other and make a scarp or a cliff, and that's what's happened here. Now you notice that sometimes these scarps are smashed by craters and other times they cut through craters. So that tells us something about these scarps. It tells us that the scarps are not just a one-time event, that they've been happening over a long time on Mercury. And so again, this is actually a nice picture right here on the right because you also see some of these smooth planes here from impact structures. Okay. So again, a lobate scarp right there slicing through terrain right there. Okay, so obviously it slices through old terrain, so the lobate scarp is actually younger than the terrain. The terrain had to be there long beforehand. But there's obviously a crater up here that's much younger than the scarp because it blasted on top of the scarp. So an impact smashed the scarp right there. So again, this is telling us something about the timeline of all this. Now, the question is where these lobate scarps come from. As I said, probably from this compression. Well, how do you compress the surface of the planet? We'll get back to that. Well, Mariner 10 also found a shock. Mercury had a weak magnetic field. It's only about 1% as strong as Earth's magnetic field. But the fact that there was any magnetic field at all was a major surprise because the moon has no magnetic field. It has hardly any core, and the core is solidified, so you don't have that liquid metallic thing in there going. Now, Mercury, they thought would have a solid core, and the other thing is to get a magnetic field, you got to rotate fast enough. Mercury rotates once, every 59 days or so. That's nowhere near fast enough to generate a magnetic field. So that means that Mercury's magnetic field is, as of to date, still not fully explained. We can't really explain it. We do know that it does have a magnetic field, though, and a magnetosphere like Earth does, just much smaller. To get the magnetic field, we do expect to have a liquid core. And again, the rotation, slight irregularities do suggest the core may be liquid. Okay. Now, how do you get a liquid core in there? Back to that sulfur we talked about with the volcanoes. Sulfur is actually going to act, if you have enough sulfur mixed in with iron, kind of like antifreeze. That means that the melting point of the iron is much, much, much lower than it would be if it were not there. So that means that the temperature can cool off to a much lower temperature and still be liquid than if there were not so much sulfur mixed in with the core. The question is, where did all this sulfur come from? Why does Mercury have so much more sulfur than everything else in the solar system? Good question. The other question is, why does Mercury even have a magnetic field, even if you have a liquid core? Because, well, gosh, it doesn't rotate fast enough. Our dynamo model of magnetic field should not apply here. So that is another mystery. We don't understand that either. We do know that the magnetic field is almost lined up with the rotational axis within 2 degrees. That's really a lot closer than most planets. the magnetosphere is asymmetric. That means that the sun's magnetic field flips, and when the field is one way, it actually interacts with Mercury's magnetic field one way. When the magnetic field is the other way, it reacts differently. And so that does indicate that there's a difference in how it interacts with the magnetic field. Again, this is not quite like the way it is on Earth. One thing that they had suspected was that the magnetic field might be some sort of temporary thing, or something that happens just happens when Mercury is close to the sun. Well, that's actually not true, because the Messenger spacecraft orbiting Mercury found that as Mercury changed distance from the sun and orientation and so forth, the magnetic field has virtually no variation in there. And so that suggests that this is a particularly stable magnetic field. And again, that's a little bit of a surprise. One weird thing, though, is that the center of the magnetic field is actually offset about 1/5 of the radius. So instead of the center being the center, it's like the center is about 1/5 of the way off. So that's a little bit different. Okay, so that's kind of an oddity right there. Okay, so they don't really understand that either. Okay. And it's also stronger in the northern hemisphere than it is the southern hemisphere. Again, that sort of asymmetry is not something that we normally see with planets. So again, whatever's happening with Mercury's magnetic field is weird, and so we don't fully understand it yet. Turns out Mercury actually has an atmosphere too. This was a complete surprise. Mariner 10 didn't see it, but after the Mariner 10 had visited, then astronomers at McDonald Observatory in West Texas were studying the spectrum of Mercury and found out there's just some sodium atoms floating around. Now, where's that coming from? Now, why did Mariner 10 not see? Well, they had no sodium measuring equipment on board. Well, duh, no one expected a sodium atmosphere. What they think is happening is solar wind particles are hitting the surface and knocking sodium atoms loose, and they're kind of flying around. Some of them land back on the surface and get knocked loose again, and others of them actually get pushed away by the solar wind, making Mercury have sort of a sodium tail pointing away from the sun. And so now we say it's an atmosphere. This is like the lunar atmosphere. It is super, super, super thin. And so this is not what you normally would think of as an atmosphere. It's still basically a vacuum. But the fact that there's anything there at all was somewhat of a surprise. It's really like the moon. It's much closer to being an exosphere than it is being an atmosphere. And again, you know, some of the stuff can be knocked loose by light hitting it and knocking things loose, solar wind particles coming in, and the solar wind particles coming in and sputtering, knocking things loose, or even microscopic meteorites hitting and knocking atoms loose. And so those atoms just kind of hang around for a while, get caught in the magnetic field. Some of them come back to the surface and some of them leave. The sodium tail has been measured several times, and it does get bigger and smaller depending with solar activity. Big shock came in 1999, in which Arecibo Observatory bounced radar off of Mercury and got a reflection very similar to that of ice. So this is right after the Clementine spacecraft found ice in the polar regions of the moon. And so they tried doing this with Mercury, and sure enough, some of these craters where the sun never shines appears to have ice in them. This planet very close to the sun with ice in these craters in the polar regions. Now again, these craters, the sun never shines in them, so never get hot. And so, you know, they just radiate energy off into space. So they are below freezing, even on this hot world, they are below freezing. And so if a comet runs into Mercury, there'll be a cloud of water vapor around Mercury, which some of it would settle in some of these craters, making kind of like a little bit of frost in there. And so, yeah, so this is just this weird discovery. Ice on Mercury. Mercury is weird in other ways. The isotope ratio on Mercury is all wrong. Remember, the propelid was like a big centrifuge which separated out different parts of the solar system. And so different parts of the solar system ended up with different isotope ratios. Mercury's isotope ratios do not correlate with what we would expect for something forming this close to the sun. So that's weird. Doesn't make sense that Mercury formed somewhere else further out and then migrated that far inwards. The other thing is that potassium content in the Mercury's rocks is way wrong for what we would expect for high temperature formation. Forming at the inner part of the propelid, you'd expect high temperature formation. And so that doesn't seem right. So, and all that sulfur is wrong. The sulfur content is out of whack also. So Mercury's chemistry just doesn't match. So how did Mercury get that way? The inner propelid may have been hotter than we thought, and so you ended up with this excess amount of iron. But that would not explain the sulfur. It would not explain the potassium. Okay. Or Mercury may have formed and then some large object hit it dead on. Remember, large object hitting the Earth. That idea worked pretty good for Earth, so they have some idea here that maybe it happened on Mercury too. I think this is actually kind of a stretch. I think, you know, the whole idea of something big hitting the Earth, making the moon, that seems to work. But when they are talking about Mercury, this seems to be just a long shot here, and you know, grasping at straws. You know, maybe it happened with Mercury too, because the idea worked so well on Earth. Okay, so but the idea being the impact stripped away almost all the crust and the mantle, and the impactor left behind the contaminants of potassium and sulfur. So maybe it happened that way. I don't know. Okay. More recently, there has actually been a suggestion that Mercury might have actually formed external to the solar system and be captured. A rogue planet that got caught by the protosun as it was forming. And so that's another possibility. Again, that seems like a long shot, but then we really don't understand. So there's still several mysteries that we don't understand Mercury, which is why we still want to study it. European Space Agency launched something called BepiColombo, a mission to study Mercury, and was launched in 2018. It was going to have a lander that land on the surface, but the lander was canceled due to budget constraints. What happens is that it launched in 2018 to out into space, then came back by Earth, let Earth's gravity toss it in towards Venus. Venus's gravity then tossed it in to another orbit that tossed in close to Mercury, and then back to Venus, which tossed it in much closer to Mercury, which tossed it in, you know, here again back towards Mercury. And eventually the idea is by 2025, then this orbit would have matched up with Mercury in such a way that it would go into orbit around Mercury. And so that's the idea right here for BepiColombo. So by 2025, we'll have another spacecraft orbiting Mercury, and that might answer some of these questions here that we don't know. We really don't know. Mercury is really a very poorly studied world, in part because it's so close to the sun. It's very difficult to study, both by space missions or by telescope. And so Mercury is probably one of the least studied of the planets. And so the more we find out about it, the more weird it looks. And so the more we want to study more to figure out what's really happening.